Hi, welcome to our STAT 1601 final project, statistically analyzing the Spotify top charts. I'm Jean Quinn.
I'm Sally Park.
I'm Zina Almuti.
I'm Alexandra.
And I'm Lauren.
Part one of our project is dataset background and description. So first off, the summary of the dataset as a whole is that we named it Spotify CSV. It includes all songs in the top 200 weekly charts of Spotify in 2020 and 2021. Its variables include the song's artist, a number of weeks charted, and other insightful information about the songs. So it has all of the variables that we're going to go into detail on later. Originally, it had 22 of them, but we removed 10 because it was a lot to work with. Our motivation for choosing this data set was that it feels very relevant to our daily lives. All of us listen to Spotify regularly. We were kind of just curious to look into the data about it. So
to give a brief description of the relevant variables that we will be looking at later on, the numeric variables one is highest charting position, and that's just the highest position song that the song reached on the chart. So if the highest charting position is 3, then the highest position was 3rd on the chart. And streams is the approximate number of listener streams the song had. That's as of 3 months ago. So a lot of these songs are still on charts, but the data set was posted 3 months ago. So it's not completely up to date. And then artist followers is just the number of followers the artist has on Spotify. And then the duration variable is the duration of the song, but in milliseconds. And then the categorical variables that we looked at were just the song name, and then the artist of the song. And this is just the main artists involved in making the song, not including the artists who were featured. And then release date is just the initial date the song was released. And the chord is just the main chord of the instrumentals of the song for the instruments, and some songs have multiple chords as well.
So this is the other portion of variables that we use, which is weeks charted, popularity, valence, tempo, and genre. Weeks charted was just like the songs had been in Spotify in the top 200 weekly global charts. So it for that one, it wasn't just like the week, it was from like one day to the other for the 7 total days. And then popularity was the Spotify made popularity index. It's songs popularity value will be like between 0 and 100, with 100 being the most popular. Valence was also Spotify made index. A song's valence value will be between 0.0 to 1.0, with 1.0 being the most positive. And then tempo was just overall estimated tempo of a track in beats per minute. And then for the category variable is just genre, and the genres of the songs belongs to and as categorized by Spotify, which was kind of messy as well.
So the second part of our project is data preparation and summary. We did a few things to clean up our original data set. So first we removed the listed variables, as we felt that they were a bit much to work with, and we didn't think we would be able to get much meaningful and insightful information from them that would help us discover like what the features of a typical top charted song look like. And so additionally, the original data set quantified the duration variable in terms of milliseconds, like we said earlier. But we thought that was too difficult to visualize, so we decided to convert it to seconds, which is more commonly used and therefore easier to visualize. And then for streams, we also decided to convert the stream variable to numeric, as it was originally categorical, and we thought we could do more with it if it was numeric.
So we decided to remove the songs that had brackets with nothing in them, or just nothing in the cell in general. And we decided to kind of condense and simplify these the genres listed into Latin, pop, R&B, rap, and rock, and everything else we just categorized as other. The categories just came out a lot smaller than the others, partially probably because of the distribution of the charts, and partially because of Spotify's messy genre categorization with the empty brackets and nothing in the cells.
Yeah, and the code we used for this was grepl and if else.
So here we used the filtering to kind of condense the release date and charting positions, and kind of make the data set smaller and easier to work with. And we mutated the release date variable to with the grepl and if else functions to turn the dates into years instead of just using the whole date in general. And we went from 2019 to 2021, and everything else is just other. We also decided to, for the highest charting position, to just use everything from top 10 and under. Kind of doing this made the data set more specific and again easier to work with, but not all the data sets that we are using are based on this one.
It went from about, I want to say roughly 2,000 variables to about 200. So it was definitely very useful for some things, but also we didn't use it for all of our data visualizations.
We also summarized our numeric variables. The summaries included the minimum, maximum, first quartile, third quartile, mean, and median. The highest charting position, we found that the mean was 88.09 and the median was 81. For artist followers, we found that the mean was 15,420,848 followers and the median was 7,601,122 followers. And you can see that there's a very big difference between the mean and median, so it's very skewed. And so when the mean is higher than the median, it's positively skewed. And so I was saying that that the artist followers is an example of a positively skewed distribution. In general, when the mean is lower than the median, it's negatively skewed.
Another thing that we did was we made a frequency table of the amount of times an artist's songs appeared on the charts. Since Taylor Swift released a lot of new albums of music recently, it makes sense that she showed up at number 1 on this frequency table. You can see like Justin Bieber, Lil Uzi Vert, Juice WRLD, BTS. These are the people whose songs are appearing the most frequently, which doesn't necessarily mean that they're the most popular or anything. It just means they released a lot of music that got really popular.
So to create a column that showed whether the song's stream and follower levels were low or high, I first removed the commas from the number of streams and changed the variable from character to numeric, as Zena was talking about. And then I found the mean number of followers, as Sally did, which was 15,420,848, and then the mean number of streams, which was 6,360,522. And then I used the mutate and if else function to determine if the streams and followers for a song was low, which meant it was below the mean, or high, which was above the mean. And then to summarize this data, I made a two-way table showing the follower and stream numbers. And you can see in that table there the numbers. And the greatest number of songs have low streams and low followers. There's 139 songs with that. And this shows that most of the songs in the top 200 charts are below the mean followers and mean streams, and the distribution would be skewed left, as Sally was talking about, especially the distribution of followers. And the purpose of creating this new variable was to use to have a binary variable in the data set to use in a logistic regression later on.
One of my favorite things that we learned from this project in general is this piece of work that I did. So after we filtered the release dates a little bit, I was a little worried that we weren't taking into account the older release dates. So I wanted to investigate into them a little bit. So I ended up sorting the data set so that release date was from oldest to newest. And I noticed that almost all of the songs with old release dates that are in the top charts are Christmas songs. There are some songs that are not Christmas songs. Dreams by Fleetwood Mac and Bohemian Rhapsody also charted in the top 100. I filtered out anything outside of the top 100 because I kind of just wanted to look at that smaller set. All of the songs that are shown kind of in this data set you're looking at right now, I added a new column to it that said before or after 2000. So you can kind of see for each song, all of these are before 2000. In the top 100, there are 891 songs after 2000 and only 19 before 2000. So I thought this was really interesting.
For part 3, we made a couple graphs for our data visualization. And our first graph was the word cloud with artists, streams, and genre. And this is just between 2019 and 2021. This word cloud uses the artist, streams, and genre variables, as I said. And the size of the artist names are based on the number of streams per charting song. And the color of the artist names are based on the genre. The bigger the size of the name, the greater the number of streams. And green is the other genre, purple is rap, teal is pop, and orange is Latin. This word cloud is much smaller than the next word cloud that we'll see, just because it was filtered between the 2019 and 2021.
This word cloud specifically, we had a little trouble with it because it was the most visually pleasing word cloud we were able to get from R. We had a little trouble figuring out how to explain the fact that it's not looking at the artist. So you shouldn't think that the Kid Leroy is the most popular artist. You should think that he had a really, really popular song.
So this second word cloud uses the artist and highest charting position only. Since the size of the artist names are based on the rank of highest charting position, the greater the size of the artist name, the higher the charting position. This word cloud is different from the previous word cloud because this takes into account the artist as a whole rather than the artist per charting song. And this word cloud also has a lot more observations because it was made from the data set that doesn't filter the dates.
So our next graph, we decided to create a box plot that shows the tempo for each simplified genre. And first, I just want to note that the R&B category was very small, so we considered the data to be insignificant. So with that being said, we found that Latin songs have the widest interquartile range and than other genres, and this ranges from about 90 to 170 beats per minute. And we also found that the Latin genre had the lowest median at about 100 beats per minute. So on the other hand, we found that rap had the highest median at about 130 beats per minute, but the median tempo for the other genre was extremely close at about 125 beats per minute. And we also found that pop has the smallest interquartile range, ranging from about 100 to 135 beats per minute. And we thought this made sense because the pop genre generally tends to follow a strict formula or format. And so a certain tempo is always popular or on the trend rising. Our next graph, we created two histograms for the numerical variables of valence and tempo across all genres. So both of the graphs, as you can see, roughly show a normal distribution of the data with a bell curve shape. And more specifically, valence can be considered to have a unimodal distribution, while tempo has a trimodal distribution due to its 3 peaks. So for the tempo variable, the most frequent data points occurred from a tempo ranging from about 100 to 150 beats per minute. And then for the valence variable, the most frequent data points occurred at a valence of about 0.5 on a scale from 0 to 1. And so this showed that across all genres, most songs were not categorized as neither being extremely cheerful and happy nor angry or depressed. They were more interpreted to be neutral.
For side-by-side box plots, when you look at the box plot with the highest charting position, you can see that the chord with the highest median charting position is chord D. However, the two variables don't seem to have a significant relationship. This contrasts with the next box plot, which has valence. And this could be significant because certain chords are associated with a higher valence, according to the data set such as A, D, and G. But it is important to take note that these chords these chords can include both major and minor chords, just because it's not specified. For scatterplots, these scatterplots are songs just released in 2019 and 2020. In the scatterplot with variables streams and popularity, there seems to be a positive relationship. As streams increase, popularity increases. But it's important to note that there is a higher density at the low end of the graph, which does make sense because it should be rare to have a very popular song. The next scatterplot with duration and popularity variables don't seem to have a linear relationship, but shorter duration in general tends to be much more common, which makes sense because most pop songs that famous artists release are shorter than songs that might not be as popular. And there's also an outlier on the graph where one song has an extremely long duration. And we determined that this outlier is probably a release from a famous artist and was popular despite the length just because the artist was very likable.
Our next set of scatterplots, the previous ones actually were piped from the data set that was a little bit smaller that focused on songs from 2019 to 2021. So I wanted to do one with all songs to see if the relationship would change at all. I found in general that basically what happens when you increase the size of the amount of data points you have. is that it might be a little harder to see the relationships, but in this case, it teaches us a little bit about the features of the variable and the limits that the variable approaches. So for example, with the first one, the data approaches a visible limit around popularity equals 80, which is interesting because it teaches you about the Spotify made index popularity. You can see that the highest charting position, like around there, those have the values of like closer to 100 above 80. But also if you look underneath, kind of where popularity is closer to 0, you can see that there are outliers at every level. So this teaches you a little bit about the index in general. Just because a song has a really high charting position doesn't mean that Spotify is going to put it as a really popular song, because it could have just been like a kind of one-hit wonder or something like that. Also, it's important to note when you're looking at that first graph that I flipped the x coordinates. Highest charting position kind of is viewed from a lowest to best perspective, so I tried to make it looked at like that. Also, with the next graph, there's a little bit more of a visible center point around which all of the data points are clustered. This coordinate, I think, would be about 270 or 75 maybe, which is interesting because it's the mean value of both duration and popularity. So this is interesting. There's no linear relationship with duration and popularity, but there is definitely a tendency of songs to exist around 200 seconds, not a whole lot longer than that.
So for our next graph, we decided to create a 3-variable side-by-side box plot using the valence, simplified genre, and chord variables. So the data shows, the graph shows that pop and rap have the most variability compared to the Latin, other, and rock genres. However, we believe this is more of a reflection of the fact that there are significantly more observations for the pop and rap genres in the data set than any other genres. As you can see on the screen, pop and rap have 500 and 600 compared to the others, which are much lower. And additionally, the other genre has the most types of subgenres embedded within it, which would account for how it has the largest range in terms of the interquartile range for valence. And then, although the data shows that there is not much variability within the Latin rock and R&B genres in terms of their chord and valence, we don't believe this is very reflective of the actual genres themselves, again, given the fact that there were not many observations within these categories in the data set to work with.
And lastly, our time series plot was with release date and streams. And according to the data set we used, there is a correlation. We can see that that there are more streams as the release year increases. So 2021 has the highest streams when compared to 2020 and 2019.
And then we did 1 and 2 sample inferences. So first we made a 1 sample confidence interval with the tempo variable. And we used the t-test code with a 95% confidence level, and found that we are 95% confident that the mean tempo in the top 200 songs on Spotify is between 121.16 and 124.2 beats per minute. And this is a pretty narrow interval considering the variation in tempo that we saw before on the graphs. And that shows that this test was effective, and we are able to narrow down what the mean is pretty confidently. Just to note, the data that we used had already filtered out all of the NA values. So that's made the data set a little smaller. And then we made a 2 sample confidence intervals, and we looked at the column that we created using the if-else function, and that showed whether the stream number was high or low, which I talked about before, and defined how the stream level affected the popularity variable. We created a 2 sample confidence interval with the t-test code, and our conclusion was that we are 95% confident that the mean popularity for the top 200 songs on Spotify with low streams is between 3.8 and 7.7 popularity units lower than the songs with high streams. And this conclusion makes sense because the more a song is streamed, the more popular its ranking would be. So the popularity of songs with low streams isn't all that much lower than songs with high streams, but it is still a noticeable difference. And the confidence interval is fairly wide, which means that we have a harder time in actually pinpointing the difference between the means. And although it does show that it is lower, it's not necessarily significantly lower. And then moving on to, we looked at how the follower level affected popularity. And the followers level in the new column we created was also either high or low, and was created using if else. And the confidence interval created from this one was less conclusive than the first, because based on the 2 sample confidence interval, it cannot be concluded whether followers being high or low affects popularity in top 200 songs on Spotify. And you can see our confidence interval produced is 0 is included in that. So we don't have any, we can't draw any conclusions from that. And this means that how many followers an artist has does not affect a song's popularity. It shows that the popularity variable isn't calculated through the number of followers.
The final part of our project, part 5, is regression. We performed both multiple linear regression and logistic regression. We're going to go ahead and move into that. So the first regression model that we made was using AIC. The AIC criterion is used to, it's kind of this code that you can put a model you make through in order to select which variables are effective predictors and which ones aren't. So if you look at kind of the model that we have there, you'll notice that some of them are good predictors and some of them are not. Popularity, the starred variable there, was a very good predictor for the circumstance that we're about to talk about. What we're trying to figure out with this model was to see if popularity, tempo, and duration affect highest charting position. We were initially going to use all of the variables in the data set for this, but we stuck with kind of our smaller 12 variable data set. And the result is we found out even if you use the whole data set, the entire thing with all the variables, 22 of them, you aren't going to be able to find any result for highest charting position. It's a very difficult thing to track looking at variables. So as a result, the data we have doesn't look very conclusive. The R-squared value for this model is very low. Only 10%, roughly 10.3% of the variability in Y, which is the highest charting position, is explained by this model. So very little of the variability is explained. And then as we made predictions, we tried to input reasonable values, 90 for popularity, 100 BPM for tempo, and about, I think it's around 2 minutes for duration. These yielded kind of weird values as well. The exact point calculation that we got for this prediction was about 156. Again, because these variables aren't necessarily really good predictors, this is just kind of a relatively low estimate because these are hard things to predict. Even with the AIC trying to select kind of the most potent predictors, and the only thing that was really able to predict the highest charting position of a song was Spotify's popularity index, which I'm sure they base on the position itself.
So for the logistic regression model, we use the tempo, stream, and highest charting positions to create the regression. And it was just kind of to see how tempo affects the streams and highest charting positions. So we found that like the odds of the tempo variables were surprisingly large, and that it was probably due to the fact that all the songs with high streams were because of the high tempos in the songs. So basically, for every 1% point increase in the tempo, the odds of the streams being high increased by 95.5%. And we kind of found this made sense because because of the fast beat in the tempo is something that people listen to more in songs. So it kind of made sense that because of the tempo, the streams are higher because people listen to the fast beat songs more, which you can kind of see in the word clouds. Like you kind of saw like Bad Bunny, BTS, and Ariana Grande. They were kind of like the most popular ones there. And something else that we found was that for every 1% point increase in the highest charting positions is the odds of the streams being high increases by 99.4%. Okay, so this marks the end of our presentation, and we'd like to thank you for listening, and thank you also, Professor, for helping us with all this as well. So thank you for the semester.
Thank you.
Thank you.